Hi everyone, today I want to talk about a different type of trig equation that we're going to be solving. In these equations we have more than one trig function within the same equation. And what that is going to force us to do is to use some of our trig identities that we learned previously, incorporating those into the equations so that we can solve them. So I want to look at this first problem separately because it doesn't necessarily fall under that category, but it is a type of problem that does come up. And if you look at your two terms, you'll see that both of them, well, first you see that there's two trig functions within this equation, right? There's tan x and there's sine x. However, there is a sine x in both of these terms, right? There's one there and there's one there. And what that means is that we can factor that out. It would be the same as if I had the square root of 3ab plus b as my equation, right? I'd be able to factor a b out of both of those terms. Well, the same is true here. I can factor sine x out of both of these terms. So when I do that, I end up with sine x, and then I have root 3 tan x plus 1 is equal to 0. So all I did was factored sine x out of both terms, and now, just like you would do with any other equation, you set both of your factors equal to 0. So I have sine x is equal to 0, and then I have root 3 tan x plus 1 is equal to 0. If I solve the one here on the right, that would give me root 3 tan x is equal to negative 1. So tan x is going to equal negative 1 over root 3. So now I have sine x equals 0 and I have tan x equals negative 1 over root 3. I'm looking for all of the solutions that are in this interval 0 to 2 pi, not including 2 pi. There's a parenthesis there, so I'm not including anything that's actually at 2 pi. So because I have sine x equals 0, whenever you see 0, 1, or negative 1 for either your sine or your cosine graph, or for either sine or cosine equation, I would draw the graph because that pretty much tells us where it's 0, where it's positive 1, where it's negative 1. So sine of x is going to be 0, at pi, and at 2 pi, but I can't include 2 pi in my answer, so it would just be at 0 and pi. And then I'm going to go over here and I'm going to say, okay, well, let's look at my right triangle. Here's my really badly drawn right triangle. So here's my 30, 60, 90 triangle. This is 1, root 3, and 2. So tangent is opposite over adjacent, so that would be 30 degrees, but this is negative. So I'm just going to put that as my reference angle because I'm not in the first quadrant, right? I'm now in, if tangent is negative, I'm in the second quadrant and the fourth quadrant. So if I'm in the second quadrant, I would do 180 minus 30, and that gives me 150 degrees. If I'm in the fourth quadrant, I do 360 minus 30 degrees, and that gives me 330. Now remember, I need my answers to be in terms of radians. So if I want to convert these to radians, remember I was 30 degrees, which is pi over 6. 150 is 5 times that, so this would be 5 pi over 6. 330 degrees is 11 times that, so that would be 11 pi over 6. So my answers are 5 pi over 6, 11 pi over 6, 0, and pi. Those are my 4 answers to that problem. Okay, other times you'll have two different trig functions where you can't just take out a greatest common factor and separate them out. If you look at problem number 2, I've got sine squared, and then I have cosine. And what that means is I'm going to have to change one of them to be in terms of the other. Now, I can't change cosine because it's in its most basic form. However, I can change sine squared using my Pythagorean identities. If you remember, sine squared plus cosine squared is equal to 1. This is on your trig identity sheet with all the different formulas on it. Okay, so if I want to solve this for sine squared, that's going to give me 1 minus cosine squared. So I can replace sine squared in this equation with 1 minus cosine squared, and then I'll have everything in the equation in terms of cosine. So I've got 2 times 1 minus cosine squared x minus cosine x minus 1 is 0. And if I go ahead and distribute, that gives me 2 minus 2 cosine squared x minus cosine x minus 1 is equal to 0. Now from there, I'm going to combine my like terms. So I have 2 and negative 1. That gives me negative 2 cosine squared x minus cosine x, and 2 minus 1 would be plus 1 is equal to 0. Now, I don't know about you, but I really don't like factoring if there's a negative out front. So I'm going to multiply through by negative 1 to just change the sign of everything. So that gives me 2 cosine squared x plus cosine x minus 1 is equal to 0. Visually, for me, it's much easier to deal with this equation than it is to deal with this one. So now I'm just going to factor, right? So I've got 2 cosine x and cosine x, and they have to multiply to negative 1 but add to positive 1. So this one has to be positive. This one has to be negative. So when I set both of these equal to 0, over here I get cosine x is going to equal 1/2. And here I get cosine x is equal to negative 1. Okay, so like I said before, as soon as you see 0, 1, or negative 1, sketch a graph for yourself. Right, there's your cosine graph. I'm down here at negative 1 at pi. So here x would be pi. Cosine x is equal to 1/2. Go back to your 30, 60, 90 triangle. If it's the angle whose cosine is 1/2 is 60 degrees. So my angle is going to be 60 degrees in the first quadrant, but it's also positive in the fourth. So that would be 300 degrees, right? 360 minus 60. If I convert that to radians, that's pi over 3 and 5 pi over 3. So my answers are pi and pi over 3 and 5 pi over 3. Moving on to the next 2 examples. In number 3, in this problem we have a double angle. So this is the cosine of a double angle. And if you remember last week when we talked about double angle formulas, we said for cosine there's 3 of them. And if you go back to your sheet of formulas, you'll see that there's 3 different choices on there for cosine of a double angle. And there's one in particular that we're going to use. We're going to use the one that has sine in it because I have a sine already in my equation. So the formula that I'm going to use is going to be, instead of cosine 2x, I'm going to write it as 1 minus 2 sine squared x. Okay, and that is directly on your formula sheet. Again, you don't need to memorize it. Just have your sheet handy so you know where to look. Right, so because I had sine in here, I had to use the one that has sine in it. And this is going to be very similar to the last problem we did in that I want to combine my like terms. So I have negative 2 sine squared x plus 3 sine x. 1 and negative 2 would be negative 1. And now I want to get rid of that negative in front, so I'm going to multiply through by -1. I'm just going to change the sign of everything. And so that gives me 2 sine x sine x. Because they have to multiply to +1, but they have to add to a negative number, I'm going to make both of these negative. Okay, so that would be outside terms would be -2x, inside terms would be -2 sine x, inside terms would be negative sine x. That adds to that -3 sine x. So here I get sine of x is equal to 1/2. Here I get sine of x is equal to 1. Again, when I see that 1, sketch your sine graph, and I hit 1 only in one place right here at pi/2. So x is going to be pi/2. The angle whose sine is 1/2 is 30 degrees. Sine is positive in the first and second quadrant. So in the first quadrant, it's 30 degrees. In the second quadrant, it's 150 degrees. So in radians, that's pi/6 and 5 pi/6. So those are your answers there. Okay, so when your equation kind of looks like it might be difficult, you're going to have to use some of your identities to alter it so that you can go ahead and just factor it. In problem number 4, this one is kind of totally different, right? I can't really simplify sine. I can't really simplify cosine at all either. So how am I going to approach this? Again, the way it's written, I can't really do anything with it. However, I can alter this equation by squaring both sides of my equation, right? So if I square both sides, it's still an equality. It's still an equation because I'm doing the same thing to both sides. So if I square the left, please don't get caught by just squaring sine and squaring cosine. You would have to do sine x minus cosine x times sine x minus cosine x. Okay, when you multiply that out, you get sine squared x minus 2 sine x cosine x plus cosine squared x is equal to 1. Now, hopefully when you see sine squared plus cosine squared, you recognize that as one of your Pythagorean identities, right? So I can rewrite this as sine squared x plus cosine squared x minus 2 sine x cosine x is equal to 1. This whole thing is going to equal 1. So 1 minus 2 sine x cosine x is equal to 1. If I subtract the 1 from both sides, we end up with -2 sine x cosine x is equal to 0, which is the same as saying sine x cosine x is equal to 0, right? So in order for the product of these to be equal to 0, that means either the sine is going to be 0 or cosine is going to be 0. And we can look at both of those cases, right? So sine is going to be 0 at 0, pi, and 2 pi, but remember we can't include 2 pi. And cosine is going to be 0 at pi/2 and 3 pi/2. And those would be your answers there. So those are the notes. Have those handy when you are going through the problems on the homework. That will help you out. Next time we'll do more trig, solving trig equations. We'll see you next time. Thanks, everyone.